Good evening everyone. Okay. My name is Chandrashekhar. I will deal with the chemistry. Today is the topic is atomic structure. Okay. I am from Spark Academy. Last week we already discussed about the mole concept. Today we are going to discussing about the atomic structure, the fundamentals of atomic structure, what are the topics are given in the atomic structure. I will give you a brief description about this chapter. Okay. If you have any doubts, you have asked in the chat. Okay. Hi Meghana, Ula, okay, hi Meghana. So if you have any doubts about the institute or any joining process or any doubts in the chemistry, you will ask. Okay. Meghana, Ula, hi. Hello, right now, okay. Am I audible? Hello, I am audible right now, Meghana. Okay. So today we are going to discussing about the main chapter, that is atomic structure. Some of the questions are asked in examination. Okay. Am I audible? Hello. Am I audible right now? Hello. Okay. Yes. Okay, Meghana. Okay. If anyone have any doubts, okay. So today is the topic atomic structure. So I will give the brief description about the atomic structure. What are the topics are covered in the atomic structure? You already aware about this chapter. When you observe in this atomic structure, you know the structure of the atom. Okay. What is atom? What is the particles? What is the subatomic number? Okay. One second. One second. Now okay. Am I audible right now? Clear? Some disturbance happened. Also, this is some technical problems. Hello, right now? Am I audible? Okay, let's go for the topic. This is the topic. Today we are going to discussing about the atomic structure. Before entering the classes, you know that our institute, okay, Spark Academy, please download the app from the Google Play Store. This is the daily schedule, daily live classes, and the class timings also here. Okay. So admission process also there, class for my nomenclature. You already know about this Yuddham and Poratam batches 499 or branches, and physically you can contact with Naranguda, maybe Patnam and easier. You already know this one. You can download the app and you will know the some of the video classes, study materials and lecture videos in these classes. Okay. And also we will provide these live sessions. Okay. To all subjects, chemistry, maths, physics. Okay. So this is the communication of live classes. Okay. Yes, can I crack the examination? Okay, definitely we will crack the examination. Okay, by following every day, by having this is the fundamentals. We will provide one courses of Yuddham or Poratam. You can join with us, or you can contact the branch physically or by calling the phone. Okay, you can contact by mobile numbers. You will ask. This is the fundamentals I am giving right now. YouTube now. In YouTube classes I am giving the fundamental which will be help to you in your examination as a free of cost. Okay. In our app you will know that is the two classes right now. We are going Yuddham and Poratam. Yuddham for the MPC and Poratam for the BPC students. Okay. Definitely you will crack the examination by following every day, by practicing. You can catch the concept and then after you can practice the questions. Then after every day your consistent practice makes you crack the examination. Okay. Okay. Can anyone? Okay, this is the system of our academy, Spark Academy, which will provide the lot of information and lot of videos here, and the evaluation also there. So when you write some examination, you will evaluation about this. So let's go for the concept. What is atom? What is atom? From childhood we are learning from this is the topic. Everybody you know that what is atom? So simply I will just explain you this is atom. Okay. What is atom? You can listen this atom. Atom is the particle which is indivisible. Okay. Indivisible. For example, you will take this any particle, you can cut into so many times. Okay. When it is not cuttable, so uncut. Okay, na? That is indivisible. When you divide it into so many particles, if you take the chalk piece, it will cut into some. For example, I am giving the chalk piece. Not every time. You can cut the chalk piece into parts until it not divisible. Until it is not divisible, it is called atom. Okay, the fundamental particles atom. So in this atom, we will observe the so many particles. Okay, so many subatomic particles are there. You already know about this. For example, electron. You already listen. Proton and neutron. Okay, this is the electron, proton and neutron. So electron is charge of negative. You already know. Positive charge as proton and neutron. So don't go for the discovery of proton, discovery of electron and discovery of the neutron. That's not need. That's no need to learn, because in the examination point of they will ask the question types which is related to the numerical and the concept wise. So from childhood we are learning that discovery of proton, JEE, Thomson models. These are the very important, but for fundamental the most important topics are the Bohr's model and the quantum model. So 90% of the question came from these topics only. Okay, some of the other small topics are there, isotopes, isobars and isocores. Okay, so you will observe this. Okay, so 90% of the question from these two topics, and from sometimes they will ask in isotopes, isobars and isocores. So today I will give the brief expression about these topics. You want a full class, please join the Yuddham or Poratam, or you will go for the any other self-prepared materials. When you go for our app, download and open our app, you will get the free material. Okay, then after they will give them. If you have any doubts, you can contact these call numbers 9133 380 8977525461. So right now I am giving the concept of the atomic structure. Okay, remaining about the joining schedules or any classes or any doubts, you can contact these numbers, or we can follow the Spark Academy online.com. So okay, they will give you answer every time. Okay, please. So add more members. Please share to your friends and you have to join them. It is very useful to them for examination point of. Is it cost? No, free of cost of no. So please join this session. Please join this session. So once again. So listen, go for the classes. So what is the fundamental particles? Electron, proton and neutron. Okay, electron, proton and neutron. So I will give the some properties of these particles which will be used to. So when go for the electron, what is the charge? Negative charge. This is the positive charge and this is the neutral. You already know about this. When related to this is -1. Okay, this is +1 and this is also neutral one, this is 0 1. So when go for the absolute charge, so you know these fundamentals, absolute charge, you will go to, this is the charge of -1.602 into 10 to the power of -19 coulombs. Okay, then go for this one, same charge but same value but charge is the 1.602 into 10 to the power of -19 coulombs. Okay, and this is the charge, you already know, this is the neutral, this is the 0 1, you already know. So when go for the mass of electron, what is the mass? 9.1 into 10 to the power of -31 kg. Okay, 9.1 into 10 to the power of -31 kg. We can write it is grams. 9.1 into 10 to the power of -28 grams. Okay, when comes to the proton charge, you can write this 1.673 into 10 to the power of -27 kg. Okay, in the same way the neutron charge has 1.675 into 10 to the power of -27 kg. So these are the values of this one. You already know, discovered of this electron discovered by J.J. Thomson model. Just you remember this one only, Thomson model. Then after proton is Rutherford model. Alpha ray scattering experiment, Rutherford model. So go for the neutron, this is Chadwick. Just you can remain this name. Now go for the further discussion on this. Okay, so when what is the simple, I will give you those. We are discussing about the, first of all I will discuss about the, for example, any element you can take, any element you will take. Okay, any element you will take, I will write like this one. For example, X element you will take, this is the atomic number, this is the mass number. Okay, so A is equal to mass number. Okay, A is equal to mass number. Next, Z is equal to atomic number. Okay, atomic number. So for this formula, A is equal to Z plus N. Okay, Z is nothing but number of protons. Okay, number of protons. A is equal to Z plus N, you will find out this formula. Oh, so using this N is equal to A minus Z. You want to find out the neutrons, you will get this formula. A is equal to mass number. A is equal to mass number. Okay. For example, you take this neon 1020. Okay, neon 1020. This is the atom, you already know atomic number 10. So what is the mass number here? A is equal to 20. Z is equal to 10. So you find out the neutrons. How you find out this one? N is equal to A minus Z. That means A is equal to 20 minus Z is equal to 10. That is called 10. So neutrons, number of protons 10, number of electrons, that is equal to the protons 10, and number of neutron also 10. In this case all are same. Okay, in this case all are same. This is the neutral atom. For giving for the charged particles, charged elements, it will be different. Either it is plus or minus. It's depending upon the loss of electron and the gain of electron. The number of electrons should be different. Okay. 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 Anyone please ask questions. Anyone please ask questions here. Okay, some of the examples I will give here. Okay, by this is denoted by the XZA. Z is equal to, you already know what is the Z here, the atomic number. Okay, the proton numbers are A is equal to mass number, N is equal to neutron numbers. Okay, here example is this. For example, you can fluorine 919. What is the number of electrons? 9. You already calculate. Number of protons also 9. You want to know the number of neutrons. A minus Z. A is equal to how much? 19 minus 9. That is equal to 10. Number of neutrons are 10. So electrons are 9, protons are 9, neutrons are 10. They will give by using this formula. Very important. Okay. These are the formula about the fundamental. Okay. So I will give explanation about the some of the topics today. I will go for the isotopes. Okay, isotopes, very simple, very simple. I will go for the isotope. Isotopes. Okay, isotopes, and go for the isobars. Then after isotones. These are the very important, very simple and easy. When you learn this one, what is the isotope, what is the isobars, what is the, so here you already know about the protons and mass number. Okay, protons and mass number. So the atoms, okay, the atoms which the same atomic number but different in the mass number. So I will take for example hydrogen. Hydrogen has 3 isotopes. I will write same atomic number. That means all are containing one atomic number, but mass difference. I will write the one of 1h1, 1h2 and 1h3. Okay, these are the isotopes of hydrogen. So isotopes means same atomic number. Same atomic number but different in mass number. Okay, very simple and very easy. You can understand. Same atomic number, yes or no, but mass number is different. Okay, this type of is called isotopes. I will write this is the hydrogen isotopes. You can write down chlorine isotopes. Okay, chlorine isotopes. For example, I will write Cl 1735 and Cl1737. In this case also you will observe the atomic numbers is same but mass is different. Yes or no? Same atomic number 17. Chlorine has 17 atomic number. Okay. Anyone please ask your questions. Okay, then go for the isobars. What are the isobars? Okay, the atoms has different atomic number but same mass number. Okay, different atomic number. Okay, that means I will take the different atomic number means different elements. Yes or no? This is 6 and this is the same. If you write this is the mass number 14 and this is mass number 14. So that means isotope has same element but isomer has different elements. Yes or no? Because the atomic number is changing. Atomic number change means element also change. Okay, you already know the elements. 109 elements are there. Okay, 100 plus elements in the periodic table. Okay, na? You already aware about the 30 elements, familiar. Everyone should learn the 30 elements up to hydrogen to zinc. Okay, hydrogen to zinc we have to learn. It is very useful to by solving the problems. Okay, so here come to the isobars. What are the isobars? What are the isobars? So same mass number but different in atomic number. Okay, I will write atomic number same in mass number but different atomic number. This is also called result. Next go for the isotones. Isotones means what is same? Okay, isotones different atomic number and different mass number. Okay, different atomic number and different mass number. But what is the same? Here you can observe this isotones. Tones N means neutrons. The same number of neutrons are the same number of neutrons here. That is why you can call it is isotones. The example for the isotone is called carbon 614 and oxygen 816. Okay, this is the constant. So you already know this. A is equal to Z plus N. Okay, A is equal to Z plus N. So you can write this N is equal to A minus Z. So A is equal to 14 minus 6. This is 8. In the same way 16 minus 8. This is also 8. So number of neutrons are 8 here and 8 here. This is also 8. This is also 8. Okay, number of neutrons. So these are called. So same means atomic number is same. It is isotopes. Different mass number. Mass number is same but different atomic number isobars. This is called isotones. So in examination they will give the some pairs which are the isotopes, which are the isobars and which are the isotones. Okay, na? You already know the mass of the electron. What is the mass of the electron? 9.1 into 10 to the power of minus 28 grams or 9.1 into 10 to the power of minus 31 kilogram. These are the, you already know, this is the very very important, you have to remember because in some questions they will ask the mass numbers. Okay, so you will practice about these isotopes, isobars and isotopes in examination point of view. Okay, then go for the some of the atomic models. You already know this. What is the atomic models? J.J. Thomson model, Rutherford model. Okay, alpha ray scattering. Okay, na? You don't need to learn about this Bohr model and quantum mechanic model. In this quantum mechanic model is very very important. I will explain about this topic. Okay, so before the dual nature of matter. Okay, some of the topic is here. You can learn this one. Dual nature of the matter. What is the dual nature of the matter? Dual nature. Dual means two natures. Matter has two natures. Matter has two. That is wave nature and particle nature. Particle nature means mass. Wave nature means movement. Okay, particle nature and movement. Mass nature is also there. So some of the important explanations are here. Okay, you write the Heisenberg uncertainty principle. Okay, Heisenberg uncertainty and de Broglie wavelength. Okay, de Broglie wavelength is called. Okay, what is the de Broglie wavelength? P is equal to mv. Okay, or you can write P is equal to h by lambda. Okay, P is equal to mv or P is equal to h by lambda. Okay, this is the de Broglie equation. Okay, some of the questions come from this de Broglie equation. Okay, some of the Bohr's equation is for that mvr is equal to nh2 pi. Okay, mvr is equal to angular moment, mvr is equal to nh2 pi. These are the some equations. Okay, in the same way Heisenberg uncertainty principle. Okay, Heisenberg uncertainty principle. Okay, see this Heisenberg uncertainty principle. What is the Heisenberg uncertainty? Delta x into delta p is greater than equal to h by n pi. Okay, where n is equal to what is 1, 2, 3, 4. Okay, this is the equation you will observe. Okay, delta x into delta p. Okay, delta p that is equal to h by 4 pi. Like otherwise you can write it is delta x into delta v greater than equal to h by 4 pi m. Okay, that means delta p is equal to m delta v. Okay, m delta v. P is equal to mv now. P is equal to mv. Okay, mass and velocity. The multiplication of mass and velocity will give the P, that is the value. Some of the questions from this also Heisenberg uncertainty principle, some of the question from the de Broglie Heisenberg relationship. Okay, so some of the questions from this Schrodinger equation also, sometimes they will ask and sometimes they will not ask. So very important, I will go for the very important topic. That is so many times asked in examination. So all of, when you please carefully listen, this is very important. Okay, okay, this is very important. Okay, so out of all models, Bohr's model is there, Rutherford model is there, Thomson model is there. Okay, out of these all one quantum mechanical model, quantum mechanical model. Okay, na? Quantum mechanical models are quantum numbers, very important topic, quantum numbers. Okay, you can write this quantum numbers. What are the quantum numbers? Okay, the behavior of electron, which will show the all type of, okay, that is the quantum number. 4 types of quantum numbers here, that is principal quantum number, this chapter is not completed in 1 hour, just I will give the brief explanation and a brief description about this, what are the fundamentals in atomic structure. Okay, atomic structure you already know, the electron, proton, neutron, and what is the mass of the electron, and what is the charge of these particles, and you have the subatomic particles are also here. So by quantum mechanics, so principal quantum number, this is denoted as n, and then go for the azimuthal quantum number. Okay, azimuthal quantum number. If you want to clear explanation and you have to very deep explanation and deep classes about this, you have to join the Poratum or Yuddham 1.0, which will give the exclusive time and the exclusive example for the examination data. Okay, this is the short time I will explain the some of the important topics in the atomic structure. Okay, then after go for the magnetic quantum number. Magnetic quantum number. Okay, this is L and this is the M and spin quantum number. Okay, spin quantum number, spin quantum number. Spin quantum number. This is the 4. This is called S. Okay, this is the spin quantum number. You will write this one. Okay. So, what is the importance of this quantum number? What is the signification of this number? So, when goes to the principal quantum number, the significance of this principal quantum number is energy of the orbit. Okay, it will tells the energy of the orbit. Okay, in the same way azimuthal quantum tells about the shape of the orbital. Okay, shape of the orbitals, orbital. Okay, shape of the orbitals. You already know the what is the orbital, S, P, D, F. I will explain later. Right now, the what is the magnetic orientation, spatial orientation of orbital. Okay, spatial orientation, which will tells the spatial orientation of the orbital. Then go for the spin. Spin means direction of the spin of the electron. Direction of spin of the electron. One is clockwise, another one is anti-clockwise. These till with this is plus half and minus half. These are the very simple. Okay. The principle of quantum number which tells us you the energy of the orbit, azimuthal quantum number which tells us the shape of the orbital, and the magnetic quantum number which will shows us the spatial orientation of the orbital, and the spin quantum number which will clear about the direction of the spin or the electron. Okay, na? Okay, that is clockwise, anti-clockwise. For example, if you take the principal quantum number n is called, it will start from the values 1, 2, 3, 4 and so on so for infinity. These are the n values. When go for the L value, you can find out the L value, that is nothing but n minus 1. Okay, n minus 1. That is called how much you take the 1, L is called 0. That is 1, 0, 1, 2, 3, 4 like this one. Okay, up to n minus 1. Okay, n minus 1. How many takes you will take the n is number, that is n. So when go for the magnetic moment number m, it is related to minus L to 0 to plus L. That means m is equal to, I will write this formula, m is equal to 2L plus 1. This is the formula. For example, n is equal to, you can write that L is equal to n minus 1. In the same, m is equal to 2L plus 1. So if you get the L value, you will get the m value. If you get the L value, you will get the n value. Okay, by using n value, you can get the L value. By using L value, you can get the m value. Then go for the spin quantum number, very easy. This is plus half or minus half. Okay, this is the situation we will be observed in this quantum number. Okay, quantum number, by using this one you can understand this. Okay, and I will give the some of the rules for the electrons filling. Okay, electron filling, I will give the some of the rules for the electron filling. Okay, right now I will explain the some of the rules of this one. Okay, what are the rules? Okay, you already about this learn Hund's rule, electron fields. Okay, na? When orbitals are like this. Okay, when orbitals are like, for example, this is s orbital, this is p orbital, this is the d orbital. Okay, the electrons are filled. First of all, these are same orbital, d orbital. If it is the filled electrons are like this. First of all, fill the all orbitals, then after it will be paired up. Okay, like this one. Okay, this is the correct one. If you take this 4 electrons in the p orbitals, for example, you write this one like this. Okay. Okay, directly you don't have to pair up this one. Okay, you can empty. This is the wrong one. Okay, now you can first of all in the degenerate orbital. What is the degenerate orbitals? The orbitals which are the same energy. All orbitals which are the same energy called degenerated orbitals. These are degenerate orbitals. Hello everyone. Anybody? Questions? Okay. In the same way d orbitals also 1, 2, 3, 4, 5. Thereafter you can fill this. This is the Hund's rule. I will explain in simple manner. Okay. You have to read this one. Okay. You have to read this one. And in the same way, Pauli's exclusion principle. Pauli's exclusion principle. Okay. That means the quantum numbers, according to Pauli's, the quantum numbers, you take the any electron, you can take this. If you take this any electron, all 4 quantum number not equal for 2 electrons. Either they have to change in one, like example, for example, these electron has same n, l and m values but different in s value. In the same way n, m, s, l and s. If you example the n value, m value, l value is same, at least you have to different in the s value. In the same way n value, l value, m value is same. That means this is plus of all numbers are same. Principal quantum number same, azimuthal quantum numbers are magnetic quantum. But there is a small difference in the spin quantum number. One is clockwise, another one is anti-clockwise. Okay. That means 4 quantum numbers are not equal in any electron. Okay, any electron of this element. Okay, na? That means 4 quantum numbers అనేది ఏదైనా ఈక్వల్ ఉండదమ్మా. ఐదర్ 3 సేమ్ అయినా కూడా ఒకటి డిఫరెంట్ ఉంటది. అదే మన Pauli's exclusion rule అని చెప్పారు. ఓకేనా? దెన్ ఆఫ్టర్ ఆఫో ప్రిన్సిపల్. ఓకే, ఆఫో ప్రిన్సిపల్ you already know this. The orbitals which is comes from low energy to high energy. First of all you can fill this 1s orbital, then after go for the 1s2, 2s2, 2p, 3s2, 3p. So first fill with these orbitals, then go for the p orbitals, then go for the. This is the order. It is related to the molar diagram. If you want to know the energy diagram, which will be order of increasing orbital. Okay, na? Order of increasing atomic orbitals. Okay, you can write this 1s, 2s, then after 2p, go for the 3s, then after 3p, then go for the 4s, 3d, 4p. This is the order of the Auger principle. It will tells the order of the energy of the orbitals. Okay, na? Order of the energy of the orbitals. It is related to the molar diagram. If you write the molar diagram, you can check in the your notebook or in any Google. You can write the molar diagram. It will show the like this one 1s, 2s, 3s. It is 2p. This is the molecular diagram. Okay, like this you will get the order of this one very easily. This is one of the very important. Okay, one of the very important. Okay, maximum you know. What is the filling? Okay, what is the filling electrons? Okay, na? I already know the Hund's rule. First of all it will be filled and then after it will be paid. Okay, this is the Hund's rule. The above principle, Pauli's exclusion principle and Hund's rule. These 3 rules are very important by filling the electron configuration. So before that you have to know the electron configuration. That is very important. You know about the electron configuration. Okay, all of you listen carefully. Write the electron configuration. What is electron configuration? So all our atoms are there 1, 2, 3, 4. I will write some of the 5 for the. What is the atomic number? Okay, What is the atomic number? Okay. So you can write this: hydrogen, helium, lithium, beryllium, boron. So and so on, 6, 7, 8, 9, 9, 10. Okay. So this is the one. So for example, first of all, I already know this. First S orbital, then after P orbital, then after D orbital, then go for the S. So you already know this is the shape of, okay na? Which quantum number is the shape of this orbital? Everyone? Azimuthal quantum number shows the shape of the orbitals. This is dumbbell and this is the double dumbbell shape. Okay na? You don't need about the F. Okay. Okay. This is the one. First of all, what is the atomic number? 1s1. So first of all, I will write this one and I will this one. So 1s1. This is the electron configuration. When go to the electron, what is the maximum electron in S? 2 electrons. What is the maximum electron in P orbital? 6 electron. What is the maximum electrons in the D orbital? 10. You have to remember this one. In S orbital, maximum 2 electrons. In P orbital, maximum 6 electrons. In D orbital, maximum 10 electrons. So when go for the lithium, this is 1s2. Okay. Okay, this one I will 1s2, 2s1. Okay, what is the? This is the 1 and this is the 2. You can write this. I will write the beryllium 1s2, 2s2. This is like you can write the 30 elements. 30 elements. Okay. When go for the boron 5, 1s2, 2s2. Okay. Then go for the 2p. Okay. This is the order of Maillard diagram. You can observe the Maillard diagram of the previous explained. Okay. So this is the electron configuration which will know the about the. Okay. So some of the problems we will be do right now in examination point of view. Okay. So you know this isoelectronic species also. Okay. And magnetic moment. Magnetic moment, you have to calculate the magnetic moment. Very very important, magnetic moments. That means mu is equal to under root of n into n plus 2. Okay, n into n plus 2 bm. Okay, Bohr magnet. N is equal to, you know what is the n? Number of electrons. Okay, number of unpaired electrons. Number of unpaired electrons. And the isoelectron species, you will listen, isoelectronic species. That is, isoelectron means iso means same. The atoms are different, but the total number of electrons are same in this species. That is called isoelectronic species. Okay, this is called isoelectronic species. One second. Okay, isoelectronic species. Okay, so I will give the some of example for the isoelectronic species. For example, you write O2 minus F minus. Okay, what is the atomic number? This one 8. You will get the 2 electrons. That means 10 electron, and F minus 9. You will get the 1 electron gain. That is, these two are called isoelectron pieces. Even though they are different elements, their total electrons are same. 10 electrons, 10 electrons. The number of electrons, total number of electrons is same in which species? It is called isoelectronic species. This is the topics we already discussed. Some of the questions we will write now. Okay. So this is our Spark Academy programming of Yuddham 1.0 for Telugu medium, English medium, EAMCET and EAPCET JEE for example. This is very low price, 4999, and the BIP students will get the Porata mind. Okay, these are the key features we are providing. We already discussed in the previous session, daily live classes, short classes, study notes and will be and focus on the previous year questions and the post exam counseling, completed online examination. These are the very important. So our methodology, okay, Spark Academy methodology, basic concept, very strong of basic concepts. We will learn the shortcut methods and we will practice the exercise, the questions of all model questions and previous year questions. And we also after that we will conduct the chapter wise examinations, weekend test and grand test analysis also there. So we will go for the problems. Okay, this is the question we will observe. So by using this concept you learn, I will give the only little bit of concept about this atomic structure. So you have to learn more and more. You have to join that Yuddham or Poratam or any online or offline classes. You will contact these numbers, you will know this. Okay, so I will solve this problem. So from the following set of quantum numbers, which set is possible? They are asking, they are giving some set and they are asking from the following set of quantum numbers. What are the quantum numbers? You already know. They are giving n value, L value and m value and s value also. That is ml means magnetic moment, ms means spin quantum number. Okay. So what is the possibility? If n is equal to 1, what is L? N minus 1. Okay. What is m? 2L plus 1. For example, you write the first condition, you have the n is equal to 1 correct. L is equal to 0, n minus 1, that is equal to 1 minus 1, 0. But what about m? M is equal to 2 into L means 0 plus 1, that is called 1. That means 1 means 1 value, not plus 1. For example, first of all you write that value as, okay, 0. This is the first value. It will comes here is 0, spin is correct. But this is the wrong one. Okay, this is the wrong one, so it is not considered. When go for the n is equal to 1, second option. Okay, I will take that red color, you will easily visible. Okay, when go for the n is equal to 1, L is equal to, is it possible? No. When n is equal to 1, L is equal to n minus 1, that is 1 minus L is equal to 0. Oh, this is the wrong one. Even though m is called right, this is the right, this is the right, but this is the wrong answer. Okay, in the same way this is right, this is the wrong one. When go for the n is equal to 3, n is equal to 3, so L is equal to n minus 1, that means 2, up to 2 you can write this 0, 1, 2, whatever it may be. There is 1, okay, this one is right, this one is. The value also 0, this one is right, and plus of this is also right. Though in the same way, fourth option, this is the wrong. If n is equal to 3, L is equal to below 2, okay, below 2, okay, 2, up to 2 you have to write the L value because L is equal to n minus 1. Yes or no? Okay, so this is the wrong one. Okay, this is the wrong one. So option C is the correct answer. Okay, option C is the correct answer. You can observe once again, if take n is equal to 3. Okay, right. What is L? N minus 1. Okay, n minus means 3 minus 1. That is L value 2. L value 2 means either you have to write 0, 1, 2, whatever it may be. Okay, the number of values are n is equal to 2, up to 2. You can write this is the 1. So 1 is applicable. Okay, then m is equal to 0. You can write this 2 into 2 plus 1. M is equal to 5 numbers 0, 1, 2, minus 1, minus 2. These are the 5 values you will observe. So this is the answer, you will get 1. Okay. You go for the second one. So gramophone record revolving with the angular. Okay. So this is the answer you will get. Okay, this is the answer. The gramophone record is revolving with angular velocity of omega. Okay, omega. You can write this one. Omega. Okay. So then after a coin is placed at distance of r to g by omega square. So I will explain. If you write it is rotated with r and omega and it is related to the m, r omega is less than mu r. Okay, this is the condition you will observe. Okay, na m or mu. What is the force of here? What is the force? Before that you can write this force m r w square. Okay, m r w square. Okay, m or w square is less than to force. Okay, F means force for this one. Okay, na? F is called force. You can write this also m or w omega, or m or omega is less than to mu r. You can write this m r omega square. Okay, m r omega square is less than equal to mu m g. Okay, na? You can write this r also mg. Okay, you already know this. You can cancel this mm. You can write this r. According to r, you can write this one. R is less than equal to, r is less than equal to, you can write this one. Omega mu g. Okay, na? Mu g by omega square. This is, where is this answer? R less than equal to mu. This is the related. These type of questions not your examination so many times, but I will give this examination. But if any example like this you will come, you can answer. Okay, this is the answer. Then go for the third one. This is very important. So many times they will ask it in examination. Okay, this is the third one. You will get one. Isoelectron piece. I already explained. What is the isoelectron piece? What is the same number of electrons are same in this pairs. Okay, na? Number of total electrons. Okay, na? Number of total electrons are same. So by using this one, you can. What is the carbon electrons? First of all, I will this one. 6 plus 18. How much? 14. Okay. Then after this is the, what is the number of electrons? 6. What is the nitrogen? 7. And this is the minus. That means one electron is adding. That means you will get the 14. What is the electron? 7. What is the oxygen? 8. But you are losing one electron. This means plus means minus. You will, minus means plus. Minus means you are getting electron. Plus means you are losing electron. Okay, right. How much you will get? 14. In the same way, carbon. Okay, carbon has how much? 2 carbons are. Okay, 12 plus 2 is there. 2. That means 14. So in this A option you will get this. All are same. 14 electrons, 14 electrons, 14 electrons and 14 electrons. These are the same. This is called isoelectron species. Either in any topic they will ask in this type of questions, which is very important. Out of this, very important this question. Please note this. In atomic structure, these important, isotopes, isobars, these are also very important. For example, we will check the another one. This is the right answer, but we will check another one whether it is right or not. It is 6 and this is the 8 and minus 1. How much you will get? 13. This is 6 plus this is 7. 13. Okay, good. These two are good. What about this one? 7 plus 18. How much you will get? 15. We are getting 13. We are getting 15. In the same way, 14 plus 1, 15. These tubes are 13, these are 15. Okay. If you take individual, you will get, these are the right, these are that. But they are asking the total isoelectron species. So this one is wrong. In the same way, you can calculate this one, you can calculate this one. These are different. Okay. You will observe this 6 plus 7, 13. This 7 plus 18, 15. Okay. These are very different. You can use 6 plus 7, 13 plus 14. These are 7 plus 18 minus 1, 16. You will get the 16. So these are the right. So answer is this one. Okay, same electrons. Okay. Next I will go for the another question. The total number of ions from the following with the noble gas configuration. First of all, you know the what is the noble gas configuration. Noble gas configuration in the outer electron, it will get NH2 NP6. For example, I will write the noble gases right now. Helium, neon, argon, krypton, xenon and radon. Okay, I will this one another element is this 118 element unknown. Okay, unknown actin. Okay, so you this is the atomic number 2, this is the 10 and this is the 18, this is the 36. You will write this 54 and 82. Okay, one another element is this is 118. Okay, 118. You can remove this one because we need this one. Okay, below 82 up to 82 they are giving this one. Okay. So first of all, strontium plus 2. What is the Z is equal to 38? They are asking Z is equal to 38. Okay. For example, strontium 2 plus. What is the Z is equal to 38? That means strontium has 38 plus 2 means they are losing 2 electrons. How much you will get? 36. Is this noble gas electron configuration or not? Okay, this is equal to krypton. Okay, this one is right. Then after CS plus, what is the atomic number of 55? But they are asking, they are giving the plus, that means -1, that is 54. It is related to the xenon atomic number. So this one is also right. Yes or no? Okay. In the same way, lanthanum plus 2. How much you get? Z is equal to 57. 57 minus 2. 57 minus 2 they are asking. It will get 55. So this is not. Okay, now this is not out. In the same way, lead plus 2. This is 82. 82 minus 2, that is called 8. It is not related to this noble gas electron configuration. In the same way, iron also and ytterbium also. Okay, this will get 68, this will get 24. These are not, these are the two only the noble gas electron configuration which is related to the number of electrons are here 54 and 36. So what is the answer? The number of ions 2. The number of ions 2. One is strontium plus 2, then after cesium plus 2. This is the answer you will get. Okay. Next, go for the fifth statement. According to the Bohr's, you can observe this. Most of the time they will ask associated reason. Okay. According to Bohr's model, hydrogen of atom, angular momentum of electron given the stationary state is quantized. Yes, mvr is equal to nh by 2 pi. Okay, this is the angular momentum. This n value also 1, 2, 3, 4 quantized. They are asking quantized. Okay, na quantized means the numbers should be 1h by 2 pi, 1h by 2 pi, 2h by 2 pi, 3h by 2 pi, like this one. Okay, na MVR is called as. First one is correct. Secondly, the concept of electron Bohr's orbit violates the Heisenberg uncertainty principle. Yes, what is the Heisenberg uncertainty principle? What is the Heisenberg uncertainty principle? At a time we cannot calculate the speed and velocity. Yes or no? Heisenberg constant delta x into delta v is equal to h by 4 pi m. This is the constant. But what about Bohr's? We can calculate the energy and the location. That is the space. At a time we will calculate this energy and this is the Bohr. Okay, na? So that means volatile is the Heisenberg constant. Yes or no? According to Heisenberg constant, we can calculate the position or velocity. Any one. Okay, at a time we can calculate the any position or velocity, any one of this one. We can calculate these two at a time. But according to Bohr's, we can calculate this and this one at a time. So that means it will violate the Heisenberg uncertainty. So A statement is correct and B statement also correct. Okay, both one line statements are correct. Yes or no? Okay. Then go for the another question. You understand this one? So you can read the Bohr's model and you can read the Heisenberg uncertainty principle. Then after you can give this statement. Then after, how many given metals are photoelectric effect? One of the important topic I already skipped. That means photoelectricity, you take any metal and you can pass this any photon, it will be eject the electron. This is called photo by using photons. Okay, by using photons, that is called photoelectric effect. You can use these first group elements. Okay, na? First group elements, potassium, cesium, these elements are using photoelectric effect. You can read the photoelectric effect. Okay, na? The light of 400 mA, they are giving the lambda. How many of the given metals show the photoelectric effect? These are the how many elements they will show the photoelectric effect. They are giving the metals lithium, sodium, potassium, magnesium, copper, and what is this? Silver. Okay, na? And this they are giving this 2.4 to 2.3, 2.25%. So when you calculate the total energy, then you can understand before that energy you will get that how many atoms are. So I will write this one. I will write this one like so. They are giving the lambda value. What is the Hc value? Okay, what is the Hc value? You already know this. Okay, now E is equal to E is equal to, this is the formula, E is equal to hc by lambda. Okay na? You already know h value 6.6025 into 10 to the power minus 34 joules, or 6.60 into 10 to the power minus 27 x, or you can write the C is equal to 3 into 10 to the power of 8 meter per second, or 3 into 10 to the power of 7 centimeter per second. You can. So lambda value they were given in the nanometer. Okay na? They will given in the nanometer. So you will convert. So first of all I will calculate the HC value. HC value, by calculating HC value you will get the value of 12,000. Okay. You can write this 1240 electron volts. Okay, HC value. Lambda is called 400. That is nothing but you can write this one into 400 into 10 to the power of minus 9. Okay. By using calculating this one, you will get the answer. You can calculate this H value, C value, lambda value. You will get the answer 3.1 electron volt. Okay. This is the total energy we require to 3.1 electrons. So how many electrons and give will show the photoelectric effect? Here this one 3.1 electron volt. This is the energy. Okay. So these three electrons, these metals 1, 2, 3. Below value, below 3.1 will show the photoelectric effect. Okay. The remaining will be not shown because the value is 3.1 electron. Okay. You will observe this. And you can understand the class. I hope you are understanding this class. From next week we will come from the another topic which will be in you can join this one. Okay, Yuddhamayan Poratam, and these are the class. These are our results. You get the highest rank of 758. Okay, so you can contact our branch for the admission, or you have any doubts in that, and then you can download the app and you can get the free material also. Okay. Free material. This is the homework questions. You will take this. This is the homework question. The value of Planck constant 6.63 into 10 to the power minus 34. The speed of light of is equal to 3 into 10 to the power minus centimeter. Which value is the closest to the wavelength of nanometer angle? You can calculate this one. Okay. Second, go for the calculate energy of joule corresponding to the light wavelength. Okay. Now Planck constant they are giving. And speed light you can calculate. Then after the total number of isoelectrons, this is the very one. Everyone should answer this one and post in the chat box. Okay, this one you can calculate the which one is the isoelectronic species out of this one. Okay, thank you. This one you can join this by using this scan. Okay, then after you go for this one. Okay, all free resource sheet is here. Okay, you can follow tinyurl.com Spark Study free material. Okay, this is the class. Okay, subscribe and share this information to all your friends. This is the Spark Academy. Okay, this is one. Okay, I hope you already all of you understand this one. Okay, so this is our academy. Please join and please share this information to maximum your members. Okay, thank you.